Alright, we want to look at circular motion, and in this video we want to introduce a few new vocabulary terms. And the period gets the capital letter T. So the period is a time, and if you think of somebody running around a track, it's the time it takes to run one lap or complete what we would call one rotation. So if you think of someone running around on a track, the period, this is the amount of time, one lap, if you're like running a track. If you were, let's say, standing and this is a merry-go-round, and the merry-go-round rotates round one time and you're back to where you start, it's the amount of time to complete a rotation. The faster we rotate, the smaller the period. If we complete a rotation in half a second, that's our period, half a second. If you complete a rotation, the faster you complete the rotation, the smaller the period. Right? So that's like the faster someone runs around the track, the smaller their time, the smaller the period. So this is period, the amount of time it takes to run one lap. Our next step is to say, what's our velocity? Well, velocity, we said, is distance or displacement. So the next thing we want to think about is our velocity. Now, when we're running around our track, we know that the arrow changes, like the direction, but the magnitude does not. So let's take a look at the magnitude, which is the speed that we're running around our track. And that's just our distance in time. So if we look at our runner, or we look at some object that's rotating, this person, as they go around the track, or you rotate, what distance do you cover? Well, if this R is the radius of your circle, you cover the circumference of the circle. So your speed equals the circumference. The circumference of a circle is 2 pi r. So you're going to cover 2 pi r, and the amount of time it takes you to cover one rotation or one lap is the period. So your speed, or the magnitude of v, your velocity here, is 2 pi r over the period. As long as you hold your speed constant, your velocity is constant, right? Just changing the direction. So you have this is 2 pi r over t, or little r. Either one. So what we can also do is we can rearrange the period, and we can see that the period then is 2 pi r over v. And the amount of time it takes you to run that distance divided by v gives you the period. So the faster you run, the smaller your time it takes, or your period, to complete one lap, which makes sense. All right, so we have period t. That's a new thing. It's the amount of time to complete one lap or one rotation, and that's a specific for rotating objects and things moving in circles. And we said that the velocity then is 2 pi r over t, and that allowed us to define t as 2 pi r over v. So we have those terms. Now we want to introduce another term, and this is called the frequency. And the frequency, it gets the letter f, little f, and the frequency is actually defined as 1 over the period. And so if the period is the amount of time to complete one lap, the frequency is the number of laps you complete in 1 second. So if you run one lap every second, your frequency is 1. If you cover 2 laps every second, your frequency is 2. How many times per second we cross our starting point? So if our runner goes 3 laps every second, or we're rotating 3 times a second, our frequency is 3. So frequency is equal to 1 over period, and therefore the period is 1 over the frequency. These two are inversely related. So frequency is the amount of number of laps or rotations per second, and period is the amount of time to complete one lap. But we can now look at period to velocity and frequency. We can now see that how these are related. So our velocity we said was 2 pi r over t, but because frequency is defined as 1 over t, that means our velocity is related to the frequency. The more number of laps we run per second, the higher our velocity, which makes sense because we're covering more distance per time. So this is our velocities. We can calculate that in terms of the frequency. The other thing we can do is we can plug in and see that we can define the frequency to be v over 2 pi r. So we have some different definitions for period and frequency, and they're all related to how quickly we move around the track. Now we want to remember one other thing from before. We had something called the centripetal acceleration, and we said that that was v squared over r. And we said that the centripetal acceleration was an inward pointing acceleration towards the center of whatever radius or curvature we were going around. And it always pointed inward. But what we can do, we can define our centripetal acceleration in terms of our frequency and our period by plugging this in for AC. So what we see when we do this is we have 4 pi squared, well, r squared over f squared divided by r, which tells us that this is 4 pi squared r f squared. Now the next thing we could do is we can say, oh, well that's if we want it in terms of frequency. If we wanted our acceleration in terms of period, we know that frequency is 1 over period, and this allows us to define this as 4 pi r over period squared. So what we can see is we can relate our centripetal acceleration to our period, which is the amount of time it takes us to complete one lap, and the radius. Or we can relate our acceleration to the frequency, which is how many times we rotate in a given second, or how many laps we complete per second. New definitions, period, frequency, and we can define our centripetal acceleration, which we looked at earlier, in terms of these new quantities.